A fair coin is tossed independently 4 times. The probability of the event, the number of times heads show up, is more than the number of times tails show up is. So I have a fair coin and I am tossing it 4 times. I am tossing it 4 times. Now I've got two options to make sure that the number of heads showing up is more than the number of tails. So I can have either 4 heads, right? I can have 4 heads, or else I can have 3 heads and a tail. So I need to find the probability of either 4 heads or the probability of having 3 heads. So when I go for the case of 4 heads, I know that here I must have a head, here again I must have a head, again a head, and again a head, which means that this probability will be the probability of getting a head in the first toss will be 1 by 2. Again, in the second toss also it will be 1 by 2, right? The third toss it will be 1 by 2, and the fourth toss also it will be 1 by 2, which means that I have to take the product of these 4 things, so that I will be getting head here and a head and a head and a head, which means that this probability will be 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2, which is 1 by 16. Now, if I go for the second case, I'm going to find the probability of having 3 heads and 1 tail. So I'll begin with making this particular point a tail. So if this is a tail, I can say that the probability of getting a head is 1 by 2. Again, the second toss, the probability of getting a head is 1 by 2. Again, it is 1 by 2. And when I go for tail in the fourth toss, it will be 1 by 2. Which means that my total probability is 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2, which is 1 by 16. This is 1 by 16. But the thing is that I am not limited to just this one particular option. Here I have got 1 tail and 3 heads. But I can very well consider a different option like having a tail here and a head here, which means that I'll be having a tail here and a head here, which means that this is also a valid option because I've got 3 heads and a single tail. So what it means is that I can have 4 such options where I have 3 heads and 1 tail. I have 4 options for having 3 heads and 1 tail, right? 4 options for having 3 head and 1 tail. So all these options will be having the same probability of 1 by 16, which means that I have to add 1 by 16 4 times. Rather, I am going to multiply 1 by 16 by 4, which means that the required probability will be 4 by 16. So I can have either 4 heads to make sure that number of heads is more than number of tails, or else I can have 3 heads and 1 tail. Again, in that case, I can have more heads than tails. If I go for 2 heads and 2 tails, I cannot say that I have more heads than tails. So these two are the only two options when I can have more heads than tails. So either this option or this option, which means that if I go for the probability, it must be 1 by 16 or 4 by 16, which means that I can add these two things so that my final answer will be 5 by 16. So my answer is D, 5 by 16. 2 coins are simultaneously tossed. The probability of 2 heads simultaneously appearing is, so you have 2 coins and you are tossing it. You toss it simultaneously. The question is the probability of 2 heads simultaneously appearing is, if this is coin 1 and if this is coin 2, you have to make sure that you get a head here and you get a head here also, which means that you have to get a head here in the first coin, and when you toss the second coin, then again you have to get a head. So I know that since that this is a fair coin, the probability of getting a head is 1 by 2. Here also it is 1 by 2. Now in this question, you have to find the probability that they simultaneously happen, which means that I have to, if this is even A, getting a head in the first coin, and if this is even B, I have to make sure that I get these things simultaneously, which means that both these things have to happen. And I know that if both these things have to happen and if they are independent events, I have to take the product. So that is P of A into P of B. I know this. So P of A, the chance of getting head is 1 by 2. Chance of getting head again is 1 by 2, which means that I have to take the product. So 1 by 2 into 1 by 2 is 1 by 4. So my answer will be option C. There are two containers with one containing 4 red and 3 green balls, and the other containing 3 blue balls and 4 green balls. One ball is drawn at random from each container. So you have two containers. You draw one ball each from each of these containers. Then you have to find the probability that one of the balls is red, the other is blue. So in the first container, I have 4 red and 3 green. And the second one, I have 3 blue and 4 green. So you have to find the probability that one is red and the other is blue. So I can get a red only from this box, right? I can get a red only from this particular container, and I can get a blue. That is the second condition. I need to get a blue from the, I have only one option. I can get a blue only from the second container, which means that from this I have to get a blue. So my question actually, if I reread the question, what it means is that I need to get a red from the first, and right, I have to get a blue from the second. So to the probability of getting a red from the first ball is favorable outcomes. I have 4 red as favorable, so 4 divided by out of 7. From the 7 I have to get a red, which means that is 4 by 7. Now to get a blue, the probability is 3 out of 7, right? 3 out of 7. Now this question, what I need to find is, I need to find the probability that one of the balls is red and the other one is blue. So I have to ensure that one is red and the other one is blue, which means that I have to find red and blue, which means that this intersection. I have to make sure that from the first container I pick a red ball, and from the second container I will be picking a blue ball, which means that it is P of R into P of B. Right. Now I know how much is P of R. I got it here. It is 4 by 7. So 4 by 7 into, I know how much is P of B, which is 3 by 7. So 4 by 7 into 3 by 7, which is 12. Right. I am multiplying it 4 by 7 into 3 by 7. So this is 12 divided by 49. So my answer will be 12 by 49, which is option C. An automobile plant contracted to buy shock absorbers from two suppliers, X and Y. X supplies 60% and Y supplies 40% of the shock absorbers. All shock absorbers are subjected to a quality test. The ones that pass the quality test are considered reliable. Of X shock absorbers, 96% are reliable, whereas of Y's 72% are reliable. Now we need to find the probability that a randomly chosen shock absorber which is found to be reliable is made by Y. So you have to find the conditional probability here, because the given condition is that out of a set of shock absorbers, you have randomly taken one which is found to be reliable. So that is an information. So the one that you have picked is reliable, and you have to find the probability that it is made by Y. That is the question. So to begin with, this is the scenario. I have X, and X supplies with a probability of 0.6, because out of 100, 60 will be supplied by X, whereas 40 will be supplied by Y. No other seller is actually selling shock absorber to this particular plant. So 0.6 will be the probability. If you have a stock, and if you randomly select one shock absorber that it is provided by X will have a probability of 0.6. That it is provided by or supplied by Y will be having a probability of 0.4. Right. Now, of those things which X delivers, 0.96 are found to be reliable, whereas those supplied by Y only 0.72. I mean, the probability is given in percentage. When you divide it by 100, you'll be getting this value. So the first thing is, you have to find the probability of a reliable shock absorber supplied by X. So the first thing is X has to supply it, and the second thing is it has to be reliable. So this thing has to happen and this thing has to happen. Maybe if you have a confusion, like if you think that the probability, if the question is like what is the probability of x supplying a reliable source to this particular plant, or rather if you find out, if you need to find out the probability of a reliable shock absorber supplied by x, it is not 0.96, it is the product of these two things, because x has to supply it first and then it has to be reliable. So I have to ensure that this thing happens and this thing happens, which means that I am going to take the intersection of these two things. One is that x applies it, the other is that it is a reliable one. So if I take the product, I know that first is that x applies it, and the second thing is it has to be reliable. So this product is P of x into P of r, because I am finding the intersection. So this is 0.6 into 0.96, which is 0.576, right? Now, the same manner, the probability of y supplying a reliable shock absorber will be the product of these two things, which is 0.288. Now, you want to find the total probability of getting a reliable shock absorber regardless of the supplier out of the total n number of, say, infinite number of shock absorbers that you have. You have to find the probability that it is a reliable one, which means that either it can be a reliable shock absorber supplied by x, or it can be a reliable shock absorber supplied by y, which means that I am ORing it. Either it can be from x or it can be from y, which means that the total probability, the probability of finding a reliable shock absorber will be sum of these two things. I have to just add these two things, because either this thing or this thing, which means that I'll be summing these two things. So I'll be getting a value of 0.864. So this is the probability of finding a reliable shock absorber in this particular plant. Now, I know that P of A given B is P of A intersection B divided by P of B, where P of B is the probability of that condition which is given. So in this case, the given condition is that it is reliable. So in the denominator, I have to write this thing, right? Because it is given that it is a reliable source. I mean, it is a reliable shock absorber. Now, in the numerator, I have to find the probability of A intersection B, where A is the condition, the probability that you are going to find, the probability, the conditional probability when a given condition is given, and here in this case, A will be that it is made by Y. So what is P of A intersection B? What is the meaning of A intersection B? A intersection B means A and B has to happen simultaneously, right? The probability of simultaneous occurrence of these two things. So this thing is getting a reliable source, I mean reliable shock absorber, and this thing is that it is supplied by Y, right? So if Y supplies a reliable shock absorber, that probability itself will be P of A intersection B, right? If B were, suppose if B were a different thing, like you are trying to find out the probability of simultaneous occurrence of getting a bad shock absorber, that is B, and getting a good shock absorber from Y. In that case, this numerator will be 0, because you cannot get a bad along with a good from Y. But here you are going to get a good from Y, and along with that it must be a good one. That is the meaning of that. You need to find the first event A is getting a good shock absorber from Y, and the second thing is getting a good one, which means that it is P of A itself, which is nothing but probability that Y supplies a valid shock absorber, which is 0.280. So when I take this ratio, I'll be getting it as 0.334. So my answer will be option B. Find the value of lambda such that the function f of x is a valid probability density function. Function is f of x is equal to lambda into x minus 1 into 2 minus x, for x lying in between 1 and 2 and 0 otherwise. That is the question. So the first thing that you need to keep in mind is that if a function has to be a valid probability density function, the total area of that function must be 1. The total area of that particular function must be 1. So if you write it algebraically or in integral format, it will be minus infinity to infinity f of x dx. So here I am taking the area. So f of x into dx must be 1 from minus infinity to infinity. In this particular case, this function is limited to a non-zero value only between 1 and 2. So from minus infinity to 1, the value of function is 0, and naturally the value of integral will also be 0 because f of x is 0. And from 2 to infinity it is 0, which means that from 2 to infinity also this area will be 0. So only I am bothered about if I draw a graph here. I do not know the shape of f of x, but if I draw it something like this, I know that from only between 1 and 2 I have a non-zero value, whereas here I have 0 value, which means that the area is also 0, and from 2 to infinity also the area is 0. So this area must be 1, which means that I have to change my limit. So I'll be checking integral 1 to 2. Now f of x has got a non-zero value in that limit, which is lambda into x minus 1 into 2 minus x, which is lambda into x into 2 is 2x minus x square minus 2 plus x. So I have taken the minus sign out, which means that this is x square minus 3x plus 2. So I'll write it minus lambda outside the integral because I'm going to integrate it to dx. With respect to x, I am going to integrate it. Lambda is a constant, so naturally I can take the lambda out. So this is x square minus 3x plus 2 dx. Now, since that there is a minus sign here, if I make it plus, I know that all that I need to do is I have to just interchange the limits. So I'll make it lambda, and my limit becomes 2 to 1. Now I'm going to integrate it. So this is x cube by 3, right? When I integrate x square, I'll be getting x cube by 3 minus 3x square by 2 plus 2x. Now this is the limit. I'm going to apply it between the lower limit is 2 and the upper limit is 1. So I'll be writing it as lambda into. Now I substitute 1 here, then subtract the lower limit, right? That is the way you do the definite integral. So 1 cube is 1 and 2. I am doing it directly. 1 cube is 1. So 1 by 1 minus 2 cube. So 1 minus 8. 7, you can do it directly. So it is minus 7 by 3. Now I have a minus 3 by 2 here. I am going to apply again the limits. 1 square is 1, 2 square is 4, so 1 minus 4 is minus 3. So I can make this minus plus, so it is plus 3. Now plus 2 into 1 minus 2 is minus 1. So this is nothing but lambda into, right, lambda into minus 7 by 3 plus 9 by 2 minus 2. And this must be 1 for this thing to be a valid PDF. So I can directly multiply the right hand side and left hand side with 6, so that this becomes 7. I mean lambda into minus 7 into 2. I am multiplying it with 6 on both sides. So when I multiply this side by 6, minus 7 into 6 by 3 is minus 7 into 2, which is minus 14, right? Minus 14. 9 into 3 is 27. 27. Then 6 into minus 2 is minus 12. The right hand side I will be having a 6. This is minus 14 plus minus 12 is minus 26. 27 minus 26 is 1. So this is lambda into 1. 6, or rather lambda is 6. So I will be getting a value of I will be getting the value of lambda as 6 for this thing to be a valid PDF. A fair coin was tossed 4 times in succession and resulted in following outcomes. The first one is head, the second one is head, the third is head, and fourth is head. Now, the probability of obtaining a tail when the coin is tossed again. That is the question. So, Those who already know this, they'll be knowing that all these are independent events, and the previous outcomes are not going to bother the next outcome, which means that the probability of getting, since that is a fair coin, the probability of getting a head in the fifth toss will be 1 by 2, and the probability of getting a tail in the fifth toss will be 1 by 2, which means that the answer must be 1 by 2. Now, if you have got any kind of confusion, you can think about this in such a manner that you have already made four tosses. You have already made four tosses, which means that you have, for 2 raised to 4, you have different, for 2 raised to 4 different outcomes, which means that you have 16 possible outcomes, right? You will be having 16 possible outcomes in 4 tosses, right? You have 16 different outcomes. Now, the probability of getting this particular thing will be 1 by 16. Head, 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 head will be 1 by 16. Like that, you will be having 15 other possible outcomes out of total 16, of which this particular one is the favorable outcome, or that thing is what that has already happened. Now, if I go for a fifth toss, I already know that I have got 4 heads in the first toss, which means that now I am restricting my samples in such a manner that for the fifth toss, I'll be getting either a head or a tail. So finally, the possible outcomes will be, since that it is given that I've got already 4 heads, the possible outcomes for the 5 tosses will be like this: H, 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 T, and H, 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 H. These are the only 2 options that I am left out if I know that the first 4 tosses are head. Only these 2 things can happen, right? Only this thing or this thing can happen. I cannot have head, tail, head, head, because it is given that the first 4 tosses have yielded 4 heads. So these are the only 2 options that I have. Now, since that it is a fair coin, these 2 things are equally likely. Since it is a fair coin, this particular outcome and this particular outcome will be having the same probability. And since that the total probability is 1 and these 2 things are equally likely, I know that this has got a probability. This particular sequence has got a probability of 1 by 2, and this particular sequence has got a probability of 1 by 2, which means that the probability of getting a tail is 1 by 2, or probability of getting a head is 1 by 2 in the fifth toss.